Awesome. Thanks, Harsha. So, and thanks again to everyone for being here. As you can see, we like to keep ourselves busy, but before jumping into all these goodies and getting them ready on 013, we felt that it was like pretty important and pretty interesting to take a look at our data lineage features. Let's start with this slide that I'm sure that most of you have already seen 1,000 times, but just to put the foundations there. So our goal with OpenMetadata is to create this centralized and shared metadata platform. We want to integrate all this fragmented metadata that comes from many different sources, data lakes, online databases, weird data scientist notebooks, right? All of these little bits and pieces that are giving us this partial view of the data platform. And once all of this is ready and is centralized and we are actually able to exploit this information, we can then create these APIs and these workflows, these little applications on top of this metadata to discover our assets, to see if the quality is good enough, to see if our pipelines are reaching at the expected time. But all of this can only happen once we have like a common language, right? Otherwise, it would be impossible to read the information from all of these places and apply it with these many different purposes. And in order to create this common language, all within the OpenMetadata project, we're also implementing a metadata standard. The goal of this metadata standard is actually being able to describe and like put names and surnames and define what are all of these entities that are powering up our data platform. What is a table? What is a database? How these different entities relate with each other? And trying also to break this barrier between when we're talking about data assets and people, right? Because data assets by themselves, they mean close to nothing. It's actually the people that's behind those that know how to exploit them, that know how to make the most use out of that. So in this standard, we're also talking about users. We're also talking about teams. We're also talking about the conversations that they have and how they interact together. So if we start from this view where our data platform can be defined with this standard that we actually use JSON schema to define, then for us, Lineage is yet another relationship. In terms of this standard, in terms of this language, we can see, okay, a table is an entity and a schema contains this table and a database contains this schema and a specific service such as Redshift or Snowflake contains this database. This kind of relationship, this kind of how we are linking these entities together, it's just a way to add this graph information into the assets on our data platform. And another view that we can bring into these relationships is in terms of lineage, in terms of upstream and downstream dependencies. And for that, we don't really care if we're talking about tables, if we're talking about dashboards, if we're talking about topics. Once we are within the language of OpenMetadata, all of these elements, they are just entities, right? And these entities, they flow and they move their information. So maybe we start with a stream and this stream is feeding the data into one table. And this table gets transformed into another table using a pipeline in between. And then the final data is used in a dashboard. All of this logical flow of information, these internal dependencies, it's what we want to bring here with the lineage. So we can just link any arbitrary entity with this lineage information. And if we zoom in into a specific entity, we can say that in the end, building lineage is building this graph relationship into all the different elements that we have in the data platform. In this case, if we just focus in this entity in the middle, I'm able to define some edges that go from an arbitrary entity to this one, and then some edges that go downstream that entity to power up other information flows. And this graph specification is what we have defined in our JSON schema, because the same way that we define users and tables and dashboards, we're also able to put into the same language how these entities are related into each other with the lineage. If we take a look at a little extract of this JSON schema of this entity lineage.json, we can say that for us, the lineage is based on a primary entity, okay, that we are focusing this graph. In this case, we're just zooming in onto that entity to get this information. And this entity is related to other nodes, any other entities, these other purple balls that we were seeing. And based on that, we can just define the edges that go from other entities into our primary entity, and then edges that go downstream. Then this means that when we are building lineage, we just need to add this edge information between the entities that are already there, because these entities have already been ingested. They already exist in OpenMetadata. We brought them up via the API or via metadata pipeline. But once they are there, we can spice things up by bringing these edges between them. So if we now focus a bit more on how we are defining this edge and which pieces of information we can bring there, we will see some interesting points. We can specify which is the origin of the lineage and which is the destination of this lineage, of this relationship, basically the two nodes from where we are building this edge. And then in this edge, we can put information such as the description. Maybe we want to specify what is powering this transformation. But also we have these lineage details properties where we can keep giving more and more information. For example, here we can specify the SQL query that might be transforming a table A to a table B. Also the pipeline, this entity reference, this pointer to another entity that lives in OpenMetadata, that it's actually running and hosting the computation of this SQL query, as well as we are going to also see this column lineage information. Because if we are, for example, relating two tables, it might not be enough to know that they are linked. Maybe we would need to just dive a bit deeper and understand which are the actual columns that have something to say about that specific transformation. If we then take a look at how we are representing this edge in terms of our JSON schema, we can see, let's keep admitting people, we can see that we have this from entity, this origin node, and this to entity, this destination node, where we just need to put the IDs of entities already existing into OpenMetadata. We can bring the description using our rich internal types of our standard. We're not talking about strings. We're talking about something that has much more meaning. We're talking that there's some markdown here that then we can parse and that we can use to actually share this information in a richer way. And also these lineage details that help us to specify what are the functions powering these transformations, or what are the columns that are being involved when linking all of these entities. And this is how we are defining our lineage, but we haven't yet told like why lineage is important. So let's just bring here like a small use case, and we have these red panda topics powering some tables, dbt using these transformations, and Airflow orchestrating all of our pipelines. Everything is stored in Snowflake, and finally just putting these bits and pieces of insights into metabase informs as dashboards. If we just take a look at each of these entities, at each of these assets in an independent way, that's good enough, but that's not great, because we are losing this holistic view on how the information flows inside our platform. So once we get this lineage right, once we are able to actually link how this information moves, what's our origin, how this transformation happens, what are our internal requirements to make sure that the insights that we want to show into the metabase dashboards are as correct as possible, here we are unlocking a next level of usage and collaboration within our platform. And we have a bunch of automation ideas that we will keep implementing in further releases. For example, what happens if this table A explodes one morning? Then maybe someone that takes care about this other view needs to be notified. So we can do an impact analysis once we get the lineage right. If there are some data quality issues in a specific table, then maybe the analysts need to be aware. Otherwise, they can see funny, weird things in their dashboards, and they might not know if that's a real variation that we need to actually investigate further, or if it's an issue that it's going to be resolved. And also in terms of just quality of live theaters, if we know that a column of a table A, it's linked to a column of this view V, maybe the descriptions should also be pushed, right? So all of these ideas, all of these automations are things that we will bit by bit keep bringing into the platform. But hopefully this also gives you like a more educated view on why we are investing so much effort in making sure that we're able to extract the lineage from as many sources as possible and exploit it and make sure that the information is correct. So currently, from where we are able to extract the lineage, there's no golden rule, right? Usually in software engineer, we hear a lot it depends. And it's true that it depends because we need to rely on the information that it's available to us, that the sources want to give us. So for example, when we're ingesting the lineage from Airflow, we use the inlets and outlets information that developers can put when they are defining their DAGs. If we are picking up information from dbt, instead we can, for example, rely on the graph structure that is defined in the catalog and manifest. If we talk now about databases, we can pick the lineage by checking the query history, right? We can parse the incoming queries, just tokenize, understand what are the ingredients that are powering that query, and making sure that we can find all of these entities in OpenMetadata and bring that lineage in. Or if we are talking about views, we know that there's a DDL behind. So during the metadata ingestion, we can bring this DDL, parse it again, and put also this lineage information into the platform. Or in the case of metabase, we can just bring the API information. But in the end, what all of these different sources of lineage have in common is that when we are talking about pushing this data into OpenMetadata, we are just going to use the API. And this is at least one of my favorite foundational features of the platform, that everything that we do, everything that you see in the UI, everything that happens in our workflows is based on the APIs. So you can still, if there's information that it's not available or that you as a developer know and want to automate, you can still use the OpenMetadata API to keep pushing this information, because in the end, that's what we are doing underlying of all of this integration of the sources. And that being said, now I will pass the word to Mayur, which is going to do us an awesome demo with different ways to actually ingest this lineage into OpenMetadata.
Thanks, Vere. Just give me a minute. Thanks. Now we'll jump on to the demo. There are several ways how we can generate the lineage in OpenMetadata. There is a manual way and there are some automated way. First, we'll begin with the manual lineage part. So I'll log into my OpenMetadata platform. Okay. Here I can see I have some database services ingested, a couple of database services, and a couple of dashboard services ingested already. To create a manual lineage, I'll pick sample data database service. It has a Shopify schema and it has a bunch of tables. Let's say I select a fact sale table. For now, if I go to the lineage tab, I see no lineage generated over here. If I want to add a lineage, I can click on this edit button and the lineage editor pops up. I can add a lineage between this table and a dashboard. Let's say the sales dashboard, the data flows from fact sale table to the sales dashboard. Now, as Perry described earlier in his demonstration, that there are two entities. So this one is the table entity and this one is the dashboard entity. And now we can create an edge between these two entities. And that is done. So the lineage has been created between the dashboard and the table. We can add this lineage between the manual lineage between a bunch of entities available in this menu. We can also add a table to table lineage. So let's say I want to add a lineage between them customer. Now, if I expand this menu, I can see all the columns available in this table. And I can also create the column level lineage manually. So let's say the customer ID is linked to the customer ID available in this table. So now we can see the edge generated here and also the column level lineage generated. And that should be saved. Okay. Now we'll move on to some manual, the automated lineages. So we can begin with the view lineage part. For view lineages, I have this categories table and a product table, and I have created a view product category from these two tables. So for demonstrating the automated lineage, I'll pick up the Snowflake instance. So as you can see, my Snowflake instance is already ingested in OpenMetadata, and my metadata lineage ingestion was successful. And I can see a couple of schemas available here. I have DBT Java and production. So inside production, I have the product and categories table available as described in the table. But I do not have yet the product category available in OpenMetadata. So I'll just create this view right now. This is my Snowflake query editor, and I'll create this view. Okay, the view got created, and to reflect the view in OpenMetadata, I have to run the ingestion metadata ingestion pipeline once again. So while this run, let's just understand the query. So I have created this product category table from products and categories table. And now we can see I have specified the columns like the product ID, product name, which are from products table, and category ID and category name from categories table. I've also given some aliases to the ID columns. So now when I go back to OpenMetadata, it is still running. Yeah, now it is done. So now we go to production. Now I can see the categories table, product categories table ingested. And I can see there are 4 columns available in this table. And when I go to the lineage tab, I can see that it has picked up the lineage, and it depends on the product and categories table. When I expand this table, I can also see there is column level lineage available. So notice that it picked up the aliases as well. So product ID is linked to PID. Now we can jump on to the lineage workflow. So I have another table. The query is similar. I have products and brands table, and I have created a product brand table, which is already available in the product, which is already ingested product brand. When I go to lineage tab, I see no lineage generated here, because if you see, the table type is regular. And if I show you the query, it is a create table query, not a create view query. To ingest this lineage for this particular table, we have to run the lineage workflow. So we can go to the ingestion tab and add a lineage ingestion. So it asks for a couple of information like the duration. So these are basically the query log history duration. So you can specify it to 1 day, and the result limit can specify it to default. And I can set the frequency here. I'll set it to default. And the lineage workflow is running for me. So while it runs, we can again see that this table depends on this table has been created from products and product brand table. And again, it's the same query. We have product ID and product name from products table, and brand ID and brand name from brands table. Okay, the lineage has been generated. And again, if we see, it has also picked up the column level lineage. And also my lineage workflow was successful. Another way to generate lineage for databases is through DBT. So in my DBT, the data flows like this. I have a couple of raw tables that depends and couple of staging table and the target table. To generate the lineage from DBT, in my metadata ingestion pipeline, I have to specify the DBT details. Currently, I do not have any DBT details, so I'll just add the DBT details. So if I edit my metadata ingestion pipeline, I see there is no DBT configuration available. So I'll just add it right now. This is the path to my catalog file, and this is the path to my manifest file. And we can submit, and the information is saved. Now I'll have to run this pipeline once again. Okay. While it runs, we can check out the manifest file and see how we pick up the information from DBT. So this is my manifest file, and when I check this out, I have a nodes property. It contains basically all the details about all the nodes available in DBT, and I see the customers. So when I go to DBT Jaffle customers, for now there is one lineage generated, which is dependent on these two tables. But when I go to my manifest file, it says that this table depends on STG customers, STG orders, and STG payments. And when I go to STG orders table, STG customers table, it further depends on raw customers. So just like described in this diagram. So we have to wait for, okay, the workflow should have got successful, and now we can see that the raw payment, the proper flow. So the raw payments get generated from the STG tables, and finally we get the customers table. We also see, so we have improved our lineage generation for DBT, and now we are also able to fetch the column level lineage through DBT. Okay. Another example of automated lineage can be dashboard lineage. So in my OpenMetadata, I have ingested metabase dashboard, and I can see a couple of dashboard already available here. I have this demo dashboard, and when I go to metabase, I have this customers table, customers chart available, which has been generated from Snowflake demo, DBT Jaffle, and the customer table that we just saw. For now, we do not see any lineage available. So to link the database, to generate the lineage between dashboard and database, we have to specify the database service name in the lineage workflow. So you can specify Snowflake demo. And we have to run this again. It will take a couple of seconds. So we can see in the demo dashboard, I have two charts available. The same charts are available here. And this particular chart has been generated from Snowflake. Okay. Now we can see this demo dashboard is linked to customers table, and which was further generated. This lineage has been generated by DBT. So we can see the entire flow of data over here. Now, I'll pass on to Perry again to explain the Python SDK for Lineage.
Awesome. Thanks, Mayur. Thanks a lot for the demo. We weren't nervous at all for having a demo effect, ingesting all these different sources and creating the pipelines from scratch. So I'm able to breathe again. Hopefully you found this interesting. And as you can see, we have many different ways, right, to bring this lineage in. And just to call it a day before that, we want to show you as well how you can use the Python SDK, our own Python client that we also use internally for the ingestion framework. So how you can plug that in your own code, in your own automations to keep bringing lineage into OpenMetadata in the most comfortable way possible. So in case that at any point you want to follow that, for those of you that are not aware, we have this, where is the chat? Here. We have this OpenMetadata demo repo where you can find kind of out of the box, a bit guided examples on how to get OpenMetadata deployed and so on. And for this case, I'm just going to use the ingredients that I have prepared here in Postgres. So if you want to give that a go, here there's a Docker Compose that will spin up OpenMetadata and a Postgres database with already some sample data in it. So I just did that before the call, and I prepared this demo Postgres service where within the public schema, we can find all of these tables. And if we take, for example, a look at the actor table, so we can see it's a schema, constraints, there's already some lineage that came from picking up the information from the view. But what we want to do now is to bring new lineage information into OpenMetadata by using the Python SDK. And to do so, I'm going to use this notebook, which is also available here. Okay, so feel free to take a look at this, just follow along. We also have some examples in the docs, but in case that you want something that will work out of the box with real data, just to follow it out, you can just spin up this small demo here. So let's start, just zooming in a bit. And the first step would be to install the OpenMetadata ingestion package. As some of you might know, this is the ingestion framework code. It's a Python package that we publish in PyPy, so you can just pip install and that out into your own laptops or your own VMs, machines, whatever you use, and start hacking with the Python client. And the first step is to create the connection to the OpenMetadata instance. In this case, I'm just importing all of the definitions here. All of these are JSON schemas. I'm going to say that a lot, but a big chunk of our code gets automatically generated from these JSON schemas. So be prepared because we're going to import a lot of auto-generated Python classes for that. And the first one here will be the OpenMetadata connection. So I have OpenMetadata running in my local host, just putting the global API endpoint, and my authentication provider is going to be OpenMetadata because I'm just using the basic authentication. So that by default means that we are just applying this OpenMetadata SSO. And in order to connect, in order to authenticate via the API into this instance, I need to pass a JWT token. If this is the first time that you try to do this, you can just go into OpenMetadata UI, click onto settings, scroll down to the bottom until you find bots, and here you will see the ingestion bot. So from this view, you can just copy your JWT token, you paste it into your notebook, and we should be good to go. For this example, I'm just using the default JWT token, so you should still be able to follow that along without any issues. So once we have this connection, we plug that into our OpenMetadata class, our OpenMetadata client, and we just check that we are able to reach the server. This did not fail, so this means that this class was available and we are actually reaching the OpenMetadata server. And the first step is actually getting the ingredients that we need, right? Because we said when we were reviewing the JSON specification about Lineage, that in order to bring the Lineage into OpenMetadata, I need to get the two nodes from where I want to define this edge between them. So the first step will be to use the metadata client in order to get some of the entities, and here we're specifying a get by name. This means that I'm going to go and I'm going to call the API by passing the fully qualified name of the entity. Fully qualified names are unique pointers into specific entity within OpenMetadata. In this case, I know that I have this demo PG service that has a Postgres database, that has a public schema, that has an actor table. So this is unique. I'm not going to have any internal clash with the entities. So we can use the fully qualified name to query that information out. But what it's interesting is that here we can pass which type of entity we are expecting to get, right? We don't want to hard code any endpoints. We don't know to have any slippery slopes when we are creating our code. So we are just going to import our table pydantic class, which is automatically derived from the JSON schema. And we're going to say, hey, metadata client, please get me something by name that I know that it's going to be a table. And we're going to do that for the actor table and the film actor. And if I run this cell, we can see how the variable that I get back is of type table. As it is of type table, I know that there are some properties that are going to be there because that's a table that follows our standard language. So I'm going to have a name, a description, some columns, etc., etc., etc. And we can take a look at how this information looks within OpenMetadata by checking the JSON description of this actor entity. This is pretty long, but once we have that, we got everything that we need. So that was pretty fast, right? Because in order for me to start bringing Lineage into OpenMetadata, I just need to get my add lineage request class and bring the required ingredients inside. So we know that we can pass a description, and then we just need to bring an edge. And this edge is going to be linking from the actor entity using its ID to the film actor entity, again, using its ID. Then this add lineage request variable, we can pass it in our metadata client and just say, hey, I need to add some lineage based on this variable. And this is going to create the lineage information and bring back how the lineage looks after that was created. So we can take a look here at the lineage, and I can see that the actor table now has two nodes that it's linked to, because we saw that it was already linked to the actor view. So now this is also linked to the film actor, and we have also the edge information explaining us how these entities are actually matched together. But if we don't want to read JSONs, that's not really great. We can still go to the UI and take a look at how these tables now got all close and together. But that's, again, that's good, but that's not good enough, depending, because maybe we have more information that we can bring here. So let's continue with the example to also bring some column level lineage in there. Here you also see a small example on like the same way that we can get an entity by name, we can also get the lineage of an entity by name. So you can keep querying this lineage graph that will be automatically populated into OpenMetadata via the workflows or by using the API on our end. We will keep creating this lineage graph so you can get this information, you can specify how deep in the graph you want to go in case you want to do some further analysis. So just leaving it here for reference in case you want to play with that. But let's jump now to adding some column level lineage information. So I'm just going to go bottom to top because it also is still based into this add lineage request object. So I'm going to specify what's my origin, what's my destination. But now I'm just going to put some of these lineage details that we were talking before, right? And these lineage details are going to have specific SQL query that we're also going to be showing on the UI in further releases. And here it's when we can specify the column lineage information. In this case, I can pass an array of column lineages where we can say, hey, this list of columns, in this case, I'm just putting one single column with the FQN. So I'm going deep into the actor table and specifying this actor ID column. And I'm doing the same for the field actor table. And I'm going to link the actor ID column from the actor table to the actor ID column to the film actor table. And just by building this piece of information here and running the cell, I get all of those details back, but it's actually funnier if we see this on the UI. So we can see how this edge was already generated for us. What this means is that we can use the automations that we already have in OpenMetadata, or if you have your own processes, you have your pipelines, your ETLs, your CI/CDs, any way where you can actually run either an API call or a bit more comfortably a Python script, or you want to use directly the Java client, you can bring as well this lineage knowledge into OpenMetadata for anyone in the company to use and to exploit. And that would be the end from the lineage demo. I don't know, folks, if you have any questions on that. Otherwise, please, Marisa, you want to continue?
Yeah, that's it for our presentations today. We've been having a lot of chat and a lot of questions going on in the background while you guys were presenting. Lots of really exciting questions coming in, lots of really great points. So thank you all so much for your participation. If anybody has any more questions, we have a couple of minutes left. If you wanted to ask your question out loud, just give everyone a moment to think if they would like to ask anything. And if not, yes, Harsha has just sent the, hey, hi.
Hi, this is Deepak. I have a question as an extension to what was just demoed. This is a great demo. Thank you for showing this. The question is, in case of non-SQL based transformations, for example, if we have a source such as Kafka and the data is going to a lakehouse table, we want to see if we can leverage this SDKs to actually say that from this field in this topic in Kafka, we are seeing this going into this table. Can we do that, or this is still a limitation with only SQL-based approach? I saw that in the code, there were two snippets, column from to, and then there was a section for SQL, and you provide the SQL, combine those together, and then form the lineage. Can we use the same pattern to specify lineage for non-SQL based transformations?
Suresh, you're on mute.
So yes, the answer is yes. We have, now added, we are saying, this is the column level lineage, and this is how it came to be. And SQL is what we are, supporting right now. And then there is also pipeline information. If we need some other kind of transformation and the transformation type, we can add that information. We can work together in the community on adding what are the kinds of transformation types that we can have, right? SQL is an example, maybe Spark, maybe, some other things. We could do that. The second thing is, right now in Kafka, we have, the Kafka schema, and that schema is just a blob of schema. Right. We are going to turn that into columns so that even Kafka itself would look like a columnar data, right? There is a schema, but there is columns and fields and all of that. The advantage is you can tag them, you can add descriptions to them and things like that. And then you can also use, from this topic schema, this column to this column, you can add column level lineage. So we can work on that. It's a, lineage is always a work in progress. It's a big ocean. when you compare, all the different kinds of systems and transformations.
Cool. Thanks for clarifying.
Hey, this is Karthik. On the similar lines, right? We have a very interesting infrastructure. So in which we use Fivetran to ingest the data, and then we use Trifactor to do some transformations. So in this case, and we use Snowflake as a platform. And if you want to bring in the lineage between, my target is Snowflake, and I have a table in Snowflake, but I want to see from where we have ingested the data and processed it. Is there a way we can have these libraries?
Yeah, so we are working with Fivetran guys closely. So stay tuned. There are going to be rich integration from Fivetran. As regards to Trifactor, right? We can see what information they have available, and if we can build that integration ourselves, or it is also possible for you to use these libraries and push the metadata. So why don't we have further conversation in Slack?
Sure, Suresh. Thank you.
Okay, wonderful. Thank you guys all for your fantastic questions. To keep the conversation going, join our Slack. Harsha has just recently sent the Slack link so that everyone can join who has attended today. And we'll wrap it up by just saying wonderful presentations from everyone. Thank you all so much for your time. Super excited to have you here and in our community. And we will see you next month in November. Thank you so much for coming.
Thank you, everyone.
Thanks, guys. Bye.
Thank
See you later.
you. Bye-bye.